Very first member of that family is lithium. I have sodium and I have potassium. Now these guys have to be stored in oil. The reason they're stored in oil is because they are extremely reactive. They've all got how many valence electrons again? Just one valence electron. That one valence electron, it turns out, is relatively easy to pull off. In fact, water can pull off that valence electron. And so we store these under oil in order to keep them from reacting. I have to wear gloves because if I don't wear gloves, the water in my hands can react with the metals. So what I'm going to do is clean off a little bit of the oil. Now, they look kind of dull. Kind of looks like, this is lithium, it kind of looks like silver that's tarnished. Have you ever seen your parents' silver that looks like it's tarnished? But a cool thing about these, kind of a couple of things that are cool about these. First of all, I can cut them open with a knife. So when I cut it open with a knife, this one's kind of hard, but when I do cut it open with a knife, I expose a nice, cleany, bright surface underneath. So that hasn't been exposed to oxygen yet, so you see how nice and shiny it is. If I put it in water, something special is going to happen. I'm going to put a little indicator. This is something called an indicator. We'll talk about this later on in the year. It's going to change colors to show that a reaction has taken place. But you're going to see other evidence of a reaction taking place in here as well. So we put the lithium in here, and it's going to kind of bubble and fizz and move around a little bit. What's coming off is hydrogen gas, and it's making a thing called lithium hydroxide, which is turning the water pink. It's going to react with the water. Now, the lithium itself, as the metal, has the 3 electrons that lithium comes with. The water is taking that 1 electron off and making it into the lithium ion. And it's kind of a blah, you know. You've seen more exciting things happen with Alka-Seltzer tablets, right? Looks about the same as Alka-Seltzer. But wait. Put the indicator in here now. As we come down the periodic table, what happens to the location of that last electron relative to the nucleus? As we come down from lithium to sodium, what's going to happen to the location of that last electron relative to the nucleus? Somebody other than Jack. You've answered every question over here so far. Getting closer or farther? It's getting farther from the nucleus. So, something that's farther away, is it going to be easier to remove or harder? It's farther away. Is it attracted more or less? It's attracted less, yeah. So it's going to be attracted less, which means it's going to be easier to remove. Sodium, these are nicer chunks. I like the sodium. Sodium also has this dull appearance. Sodium is a lot easier to cut, though, because the electrons are holding the sodium together a lot less strongly, and we'll talk about the bonds that hold metals together in Chapter 8. It turns out that it's a lot easier to cut the sodium open, and so I can cut off the corner. It's like cutting cold butter. And again, we get that nice shiny surface on the inside. Now what happens with sodium is because that electron is easier to remove, it's going to react a lot faster. Now occasionally we'll get an explosion. I'm using about the same size piece to show you how the 3 metals are going to react. I'll put a bigger piece of sodium in to give you an explosion. So a larger reaction. It has formed a ball because it's so hot now that it's melted. And it's formed this ball. You see the sparks coming off? Reacts a lot faster. What's that? Okay, I'll leave that out. We'll do the potassium next, and then I'll come back and do the explosion with the sodium. Potassium is so reactive that they only sell it to us in these little pieces now. When I was your age, they sold it to us in big chunks. But they sell it to us in these little bitty pieces now. This is the biggest piece of potassium that we can get. It's squishy. It's soft like warm butter. It cuts open extremely easily. And again, we cut it open and there's this nice shiny piece inside. Nice shininess. But potassium has a special ability. Just this little tiny piece. Watch what happens when I put it in water. The hydrogen gas just caught fire. And you notice, did anybody see a little purple tint to that flame? Remember the flame test? The potassium was that purple color. So this caught fire right away. Okay. Let's put a little bit bigger chunk of sodium in here, because everybody likes to see an explosion. So I'm going to put a little bigger chunk in here. Try to guarantee an explosion. I'm going to cut it open a little bit more. And this is why we do this in the hood, in the fume hood. All right. And that's why I've got this splash shield up here. Come on, give me my explosion. There we go.
Whoa!
Wow, that was a bigger explosion. Everybody's ears okay? All right.